This lecture is about section 5.1.5.2. They're dealing with the rules of exponents. Let's review what we mean by exponents. First of all, let's go all the way back to multiplication. Multiplication is just repeated addition. That is, if I have 2 plus 2 plus 2 plus 2 plus 2, that's 5 2's, so it's 2 times 5. Well, all exponents are repeated multiplication. So if I had 2 times 2 times 2 times 2 times 2, that's 2 to the 5th power. Let's do a little bit of definitions. When I talk about an exponent, like 2 to the 5th, this 2 is called the base of the exponent. The 5 is called the exponent. If I wanted to do this on the calculator, all I would do is type 2 and then use this caret and then to the 5th power and enter, and it would give me the answer 32. Let's do some examples. Well, we just did 2 to the 5th and we found out that was equal to 32. Let's go ahead and do this negative 1/3 first without the calculator. I'm first doing this by writing out the multiplication 4 times. Negative 1/3 times negative 1/3 is positive 1/9. That's because a negative times a negative is a positive. Now if I do 1/9 times negative 1/3, I get negative 1/27 times negative 1/3. And if I do that final multiplication, I'll get a positive 1/81. And that's my answer. Now let's look at negative 2 to the 3rd. This is equal to negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is a positive 4, and when I multiply that positive 4 by a negative 2, I get a negative 8. And this is a really important pattern to notice. If my exponent is even, I end up with a positive value if I'm raising a negative number to a power. If, however, my power is odd, then I'll end up with a negative number. Again, this is assuming that the number inside the parentheses is in fact negative. And anything to the first power is just itself. So 4 to the first power is just 1. I do want to take a moment to talk about a very common mistake. If I have negative 2 to the 4th, well, I've just said since the exponent's even, that's going to be a positive result, and that's going to be positive 16. If, however, there is no parentheses, the exponent only affects what it touches. So this 4 is only raising the 2 to that power. So that means I have negative 2 times 2 times 2 times 2, or negative 16. So if that negative sign is outside of the exponent, that is, it's not in the parentheses, you don't count it as part of the exponent. The other kind of odd thing with exponents is something like, let's look at 10 to the 5th, 10 to the 4th, 10 to the 3rd, 10 squared, and then 10 to the 1st. Well, 10 to the 5th is a 1 with 5 zeros. So the number of the exponent is the number of the zeros. So 10 to the 4th has 4 zeros, 10 to the 3rd has 3 zeros, and 10 to the 2nd power has 2 zeros. And I've just said that 10 to the 1st power, well, anything to the 1st power is just itself. So if I asked you what would be 10 to the 0 power, what pattern do you see here? Well, it turns out that anything to the 0 power is just 1. Let's go ahead and check this on our calculator. 10 to the 0 power, let's do a really crazy number. Let's do a negative number. And again, I'm going to put that in parentheses in order for that negative number to be part of my exponent. The only weird thing is you cannot raise 0 to the 0 power. If you try, you'll get an error. So you cannot raise 0 to the 0 power. But that's the only one you have to worry about. Now let's look at the laws of exponents. And our first law is going to be the product rule. Let's see if we can figure out what the product rule would be. Product means multiplication. So if I have 2 to the 3rd power times 2 to the 5th power, if I wrote this out in terms of repeated multiplication, I would have 3 2's multiplied together and then 5 2's multiplied together. And I would end up with a total of 8 2's multiplied together for 2 to the 8th. Well, this indicates that my product rule looks something like this. If I have x to the a power times x to the b power, that's simply x to the a plus b. Just like here I had the 3 and the 5, and 3 plus 5 is 8, if I have any general exponent with the same base, and if I'm multiplying those together, I simply add the exponents. So that's our first rule. So I'd like you to pause the video, go to page 363 in your textbook, and work on practice number 3. Alright, let's go ahead and review these. 10 to the 8th times 10 to the 4th is simply 10 to the 8 plus 4, or 10 to the 12th. Just because we have negative numbers in our exponents, we're not going to change our rules. We're still going to go ahead and add the exponents, and I'm going to get negative 4 to the 6th power. Again, be very careful to include the parentheses, because if you wrote this, it would be a wrong answer. Alright, question C is just trying to show that it doesn't matter if I have a number or a variable, it still works the same. We still have the same rule. This one's trying to trick you by throwing a 0 in there, but remember 5 plus 0 is still just 5. And if you remember that y to the 0 power was just equal to the number 1, that's another way of looking at it. Question E, though, you cannot combine. And why? Well, because the bases don't match. If we go back to the product rule, we see that it's x to the a times x to the b. The bases of the exponent must match in order for us to use the product rule. So for problem E, there's nothing we can do. Now we're going to talk about the quotient rule. Instead of multiplying two numbers together with exponents, we want to know what happens when we do a division, that is x to the a divided by x to the b. Well, let's look at that. If I had, say, 2 to the 3rd power divided by 2 squared, that's 2 times 2 times 2 in the numerator and 2 times 2 in the denominator. We can see that we could divide out that pair of 2's and divide out that pair of 2's. And what I'm left with is 2 over 1, or just 2. So 2 to the 3rd divided by 2 to the 2nd works out to be 2 to the 1st. So our quotient rule is simply, instead of adding our exponents, we're going to subtract them. And again, I'd like you to turn to the textbook and go to page 364, and I want you to do both practice number 4 and 5. Alright, so practice number 4. Question A, it's simply 7 to the 7th minus 2, or 7 to the 5th. For question B, to be honest, I would rewrite it as a fraction. I'm more comfortable with working with division in terms of fractions, and then I have an easier time seeing that this is negative 9 to the 6th minus 5, or simply negative 9 to the 1st power. And I don't have to write to the 1st power, because if there's no exponent there, we assume it's to the 1st power. Question C, s to the 10th divided by s to the 10th. That's simply s to the 10 minus 10, s to the 0, or that's equal to the number 1, which quite frankly you could also do simply by simplifying this fraction, that when you divided s to the 10th divided by s to the 10th, you would get the number 1. For D, we have r to the 8th divided by r to the well, it just says r. Again, if there's nothing there, we're assuming an exponent of 1. And I usually write that in because it's easier for me to see then that this is really r to the 7th power. And E, again, we can do nothing to because A and B are different bases. So E, we can't do anything to. Now let's look at practice number 5. Practice number 5 is asking you to combine the product rule and the quotient rule together. Alright, what A is having you do is realize that if I have a bunch of multiplications, that's the same thing as just adding together all the exponents. So y to the 2nd times y to the 3rd times y to the 4th is just y to the 2 plus 3 plus 4th power, or y to the 9th. For question B, we need to remember that multiplication is commutative. That is, I really didn't need these parentheses because this is all multiplication. And I can rearrange this so my x's are together and my y's are together. And now I can simply add my exponents of the x's and add the exponents of the y, and I get that b is equal to x to the 5th, y to the 6th. You could also do this by simply writing out the number of repeated multiplications you have, and then add the number of x's, there's 5 of them, and add the number of y's, and there's 6 of those. For part C, before we do our division, we need to combine this a times a to the fourth in the denominator. Again, I'm going to rewrite that as a to the first specifically so I can see that I'm dealing with a to the first plus 4. So I have a to the seventh divided by a to the fifth, and now I change that to a subtraction of the exponents, and my answer is a squared. Now we want to talk specifically about negative exponents. I know what 2 to the third is. I know what 2 squared is, 2 to the first and 2 to the 0 power. But what happens when I take things to a negative number? What is 2 to the negative 1? Well, let's think about this. Let me give you a problem where we have 2 to the third divided by 2 to the fourth. If I do this by writing out my 2's, I see that if I divided out 3 2's in the numerator and 3 2's in the denominator, what I would end up with is 1/2. So if I also thought of this as using the quotient rule, then this would be 2 to the 3 minus 4, or 2 to the negative 1 power. So all negative exponents do is take the reciprocal of the base. Let's write this in general. X to the negative a power is simply equal to 1 over x to the a. So if I had something like 5 to the negative second power, the first thing I do is rewrite that 5 as 1 over 5, and now it's going to be to the positive 2 power. We can also think of negative exponents the other way around. If I have 1 over x to the negative a, this is rewritten as x to the positive a. X to the negative a, that becomes 1 over x to the a. If I have 1 over x to the negative a, that equals x to the a. So I want you now to turn to your textbook, first on page 365 and do practice number 6. And then turn the page and do practice 7 and 8. Alright, let's look at these. First of all, 9 to the negative 2 is just 1 over 9 squared, which would be, if we multiplied this out, 1 over 81. And I do want to show how we would do this on the calculator. I would simply say 9 raised to the, and I'm going to use a parentheses because I want it to be to the negative 2 power. And I get a decimal, but if you know the little trick on the calculator, which math teachers hate, if you press math and then hit enter for to a fraction, it'll convert that decimal into a fraction, and then we'll see the answer is 1 over 81. Keep in mind on an exam you can use your calculator to check, but I will expect to see the work on the paper. N to the negative fifth power is simply 1 over n to the fifth. And this question C, this negative sign, which never gave anybody trouble before, suddenly students try to start using that for the reciprocal. But that's just our standard negative sign that's outside of the exponent. We're not going to treat that any differently than we used to. We'll still leave that outside. But now we're going to change this to 1 over 3 to the y power. You could leave it in this form, or you could simply write it as this. Actually, this is a good moment to say that no matter how I write this negative sign, negative 1 over 3y equals negative 1 over 3y equals 1 over negative 3y. These are all equivalent ways of writing, as well as the first one with the parentheses. And finally, D is simply 1 over 5 to the third power. And if I wanted to multiply that out, that's 1 over 125. These problems I love because it really puts everything together. For instance, let's look at A. We've got this exponent, this to the negative 1 power. And we also have this s out there. But the s has no exponent, so it stays in the numerator. But this 8 to the negative 1 power, that means we're going to find its reciprocal, and the reciprocal of 8 is 1 over 8. So this becomes s divided by 8. The same thing with question B. That 3 does not have the exponent associated with it, so it stays in the numerator. But the x, it was x to the negative 1, so now that x, we take the reciprocal of it, and it goes in the denominator. This question just uses the quotient rule, but then we notice that the question states only to use positive exponents. So that means we cannot leave it as r to the negative 6. We have to write our final answer as 1 over r to the 6th. Alright, this problem, 3 to the second power, that's just 9. And then I have g to the negative 1 plus a negative 4, because I'm using my product rule. So that's 9 times g to the negative 5, and this is 9 over g to the 5th power. So again, that 9 is not part of the exponent, so it doesn't get put in the denominator. And 1 over x to the negative 3rd power is simply x to the 3rd power. We take the reciprocal of 1 over x, and we get x. Let's quickly go through practice 8. Question A is simply a to the 3rd power. That a to the negative 3rd was in the denominator, so we move it up to the numerator. This problem, the trick is to realize you don't move the 5. Only the x gets moved up to the numerator. And finally, for part C, the s gets to move up and the 2 stays behind in the denominator because it didn't have the exponent associated with it. Let's wrap things up with a couple more rules to round things out. We're going to talk about the power rule of exponents. We've already talked about how if I have x to the a times x to the b, that's equal to x to the a plus b. If, however, I have x to the a raised to the b power, well, that works out to be simply x to the a times b. So if you think about order of operations, what comes first is exponents, then multiplication, then addition. So what happens with these exponents is it sort of drops down a level. What was multiplication becomes addition, and now what was a power becomes multiplication. So this is our power rule of exponents. And let's see this out. If I had x squared to the 3rd power, this is equal to x squared times x squared times x squared, which would be x to the 2 plus 2 plus 2, or x to the 6. And now with our power rule, we see this is the same thing as x to the 2 times 3. We can expand this power rule to include something like x times y to the a power. This is equal to x to the a times y to the a power. So this is an extension of our power rule. What I want to warn you, though, is if I have x plus y to the a power, this does not equal x to the a plus y to the a. This power rule only works if it's a product, if I'm talking about multiplication. Once I do addition, this doesn't work. We can kind of see this with raising something to the 2nd power. You should all be familiar with this. A lot of times people call this the FOIL method. You do the first terms, you multiply the outer terms, you multiply the inner terms, and then you multiply the last term. So you end up with x squared plus 2xy plus y squared. And you can see if I had just said this was x squared plus y squared, I would not get the right answer because I'd be missing that 2xy term in the middle. So go ahead now and do practice 1, 2, and 3, and those are on pages 372 and 373. Pause the video and come back when you're done. Alright, first let's look at the practice 1. 2 to the 3rd power raised to the 2nd power is simply 2 to the 3 times 2, or 2 to the 6th, which happens to be equal to 64. 7 to the 3rd power raised to the negative 1 power is 7 to the 3 times negative 1, or 7 to the negative 3rd power, or 1 over 7 to the 3rd power. And this happens to be 1 over 343. This is q to the 2 times 4, or q to the 8th. And that pesky negative sign will throw everybody off, but we're going to leave that outside. This is simply p to the 3 times negative 5, or negative p to the negative 15th power, or negative 1 over p to the 15th power. For practice 2, this is just 7 squared times a squared, or 49a squared. Watch your parentheses here. That negative sign is inside the parentheses, so I have negative 4 to the 3rd power times x cubed, or negative 64x to the 3rd power. Remember, if I have an odd exponent and I'm raising a negative number, I end up with a negative number. What's interesting is we end up getting the exact same answer for this 3rd question in practice 2. That negative sign sits outside, 4 to the 3rd power is again 64, and then we have x to the 3rd. This negative sign came from being inside the exponent being raised to an odd number. The second negative sign is just there because it was a negative number. For practice 3, this is positive 36. Again, a negative number raised to an even number is positive. And then a to the 2 times 9, or 36a to the 18th. q to the 8th to the 2nd power, r to the 10th to the 2nd power, q to the 8 times 2, r to the 10 times 2, or q to the 16th, r to the 20th. That negative 2 is just going to sit outside. We have a to the 3rd, b to the 7 times 3, or negative 2, a cubed, b to the 21st power. And our last one, 7 squared, a to the negative 1 squared, and c to the negative 5th squared. Notice I don't worry about switching things to reciprocals until I'm all done. I try to do just one thing at a time. 7 squared is 49. Then I have a to the negative 1 times 2, and c to the negative 5 times 2. 49, a to the negative 2, c to the negative 10th. My final step is to get all my exponents positive, so that means a squared and c to the 10th go in the denominator. Finally, we have the same kind of properties with quotients. That is, if I have x divided by y to the a power, that's equal to x to the a divided by y to the a. Another property that's useful to know is if I have x divided by y to the negative a power, that's the same thing as y over x to the positive a power. And that'll often make your life easier in terms of simplification. So for one last time, go ahead and turn to your textbook. I want you to do practice 4 on page 374, and then practice 5 on page 375. If I have y over 3 to the 2nd power, that's simply y squared over 3 squared, or y squared over 9. This is another problem that people will make mistakes with. That negative u is raised to the 10th power. Do not move the u to the denominator. It's only if the negative sign is in the exponent that it moves. And it might be sounding like a broken record, but I promise you there will be at least 3 people in the class who will make the mistake and rewrite this as 1 over u instead of leaving u in the numerator. The exponent is even. It ends up being a positive result, so I end up with u to the 10th divided by v to the 10th. For this next problem, the first thing I'm going to do is take care of the negative sign. I'm going to write this as y over 3 squared, or y squared over 3 squared, or y squared over 9. This next one starts getting complicated. I'm going to take that squared and apply it to each and every factor. And now I'm going to do some simplification. Negative 10 squared is just 100. A to the 5th raised to the 2nd power is a to the 10th. That's 5 times 2. 3 squared is 9. B squared raised to the 2nd power is b to the 2 times 2, or b to the 4th power. And finally, c squared. Then we have 5 to the 3rd, x to the 3rd, divided by y to the negative 2 raised to the 3rd power. 5 to the 3rd power is 125, x cubed, and the denominator has y to the negative 6. Again, it's negative 2 raised to the 3rd power, or negative 2 times 3, which is y to the negative 6. But I can't leave it like that because I always have to have positive exponents, so that y to the negative 6 becomes y to the positive 6 in the numerator, or I could simply write this without the divided by 1, or have 125 times x to the 3rd power times y to the 6th. And those are our laws of exponents.